Hey everyone, let's start with the simple machine learning algorithm called simple linear regression. This is the first machine learning algorithm we will be understanding in this session. Not only that, with the help of SKLearn library, we will perform some hands-on to see how we can use linear regression in a Python code. From our previous session where we have discussed about the machine learning fundamentals, we have realized supervised learning is a domain of machine learning. Supervised learning can further be categorized into regression and classification. Based on the different types of problems we can solve with the help of supervised learning, we have categorized the whole supervised learning into two broad categories called regression and classification. Simple linear regression is nothing but an algorithm comes under regression. Let's understand what is regression. Regression is a technique to establish the relationship between variables and predict a continuous value based on the relationship. Here, continuous value means a numeric value. For example, if we want to predict the price of a house based on the area in square feet of the house, we will be using regression model. Let's now understand what is the difference between dependent and independent variables. The variables are called dependent variables for which we will perform the prediction. In our case, house price is a dependent variable. On the other hand, variables we manipulate or control to influence dependent variables are known as independent variables. Here, area in square feet is an independent variable. Basically, independent variables causes an effect on dependent variables. Now, let's understand what is linear regression, a technique to find out linear relationship between dependent and independent variables in order to predict the dependent variable is known as linear regression. As the relationship is a linear relationship, we can represent the same with the help of linear equation. Here y dashed equal to mx plus b. I think all of you are aware about the linear equation y equal to mx plus b, where y is nothing but the dependent variable, m is the slope of the line, x is independent variable, and b is the intercept. Slope represents the magnitude of change in y when we change one unit of x. What is b or intercept? When the value of x is 0, what is the value of y of a straight line is known as intercept. So in case of linear regression, using this straight line equation, we can establish the linear relationship between dependent and independent variables. We can put different values of m and b to come up with different straight lines or different linear relationship. However, which one to choose? Which one will be the best relationship? In order to identify that, we have to evaluate the errors for each and every straight lines we have. Errors are nothing but predicted values minus actual values. Once we evaluate all the errors, we can sum up all the absolute errors. And our target is to find out a linear relationship or a straight line which has lowest sum of absolute errors. And that will be the best relationship. Linear regression internally does the same. How it is evaluating lowest sum of absolute errors, we will see in our subsequent sessions where we will be discussing the internal mathematics behind linear regression. However, for now you have understood how we are coming up into a single line of regression from a number of possible straight lines we can draw with the help of y equal to mx plus b equation. Now let's see how with the help of Scikit-learn library in Python we can use linear regression model and predict housing price. SKLearn has a model called linear regression This model has been defined already within SKLearn library, and this gives us ease to use it directly in our code. In order to use linear regression, we have to import it from sklearn.linear model. Import linear regression is the command to import linear regression in our source code. We can instantiate the model with the help of linear regression constructor. Fit is the method with which we can train a model. Fit takes two arguments, xtrain and ytrain. These are nothing but the training data. With the help of this training data, your linear regression model will identify the best value of m and b. That means best value of slope and intercept. Once your linear regression model has identified the best linear relationship with the help of y equal to mx plus b equation, we are ready to predict the dependent variable. In order to predict, you have predict method in sklearn library. Model.predict will take one single argument, which is nothing but the independent variable, and predicts the dependent variable accordingly. We can even evaluate the accuracy of the model with the help of score method. Score method takes test data. First one is the independent variable and second one is the dependent variable. Enough of theory. Let's jump into the Jupyter notebook and write some code to use linear regression of Scikit-learn library. Here in this notebook, initially we tried to install Scikit-learn. We can use pip install in order to install Scikit-learn library in our machine. In my case, I already have Scikit-learn in this machine and hence it is telling you requirement already satisfied. Once you have installed Scikit-learn library in your machine, you have to import the machine learning model which is required for your use case. Apart from the machine learning model, we also have imported pandas in order to perform the data collection and cleaning. We have imported matplotlib, which is nothing but a visualization library to visualize data as and when needed. In my machine, I have housing price dataset what I have downloaded from Kaggle website. I'll be using this CSV file as an example dataset. Let's see what is there within this dataset. If you see here, there are a number of attributes of a house and the corresponding price of those houses. In our case, we will only be using square feet column in order to get the size of the house, and we will try to establish the linear relationship between size of the house and the price. Hence, we only need these two columns, square feet and price. Under cleaned housing data frame, we have only two columns, area in square feet and the price of the house. And for simplicity, I have only taken 20 records from the source data frame. With this, we are ready with our dataset. Let's see our dataset with the help of scatter plot. I have created a scatter plot using matplotlib. If you are not aware about matplotlib library, I have a whole data visualization series where we have explained not only matplotlib but Seaborn library as well. I will be adding all the links in the description. Here, as you can see, we have plotted the data points here. Now, our target is to train our model with the help of these data points so that our model will have the capability to predict price of a house of size 2600 square feet. Let's see how can we do so. In this step, we are creating a model which is nothing but a linear regression model. Remember, this model has the ability to find out the best linear relationship among a number of possible linear relationships on these data points. We will see the math behind this linear regression model in our subsequent session. In order to understand how linear regression model is identifying the best linear relationship. Once you have model, we can train the model with the help of fit method. Model.fit takes two arguments. One is sample of independent variables and the sample of dependent variables. That is why it is a supervised learning algorithm, because it is taking the labeled data for training. Once training has been done, our model is ready to predict a dependent variable based on a specific independent variable value. Here we are trying to predict the price of a house which is of 2600 square feet. It is showing you the predicted price of the house. Let's visualize the predicted price so that we will have some idea of the prediction. Here if you see, the green dot is nothing but the predicted value. There was no entry in our training set for 2600 square feet. However, your trained linear regression model has predicted the price which is nearly 280k. Predict method can also take a list of independent values in order to predict the list of dependent variables. With the help of matplotlib, we are trying to plot the regression line. If you see this code, we are putting all the data points in a scatter plot, the predicted individual value in the scatter plot as well. And here we are plotting the regression line, whatever we have predicted here. So we are passing this as x-axis and y underscore predict as y-axis in order to plot the regression line, and regression line will be plotted in green color. Again, if you are not aware about matplotlib, you can watch my data visualization playlist in order to understand not only matplotlib but Seaborn library as well, which is more advanced than matplotlib. Data visualization is very critical for a data scientist. Hence, you should learn data visualization as well along with machine learning algorithms. Let's run this to see the output. If you see here, our linear regression model has identified the best linear relationship by evaluating the minimum sum of absolute errors here. Let's understand the takeaway from this session. We realized simple linear regression is a regression model which is a part of supervised learning of machine learning. Using linear regression model, we establish the linear relationship between dependent variable and independent variables. Now we even know what is dependent variable and what is independent variable. For example, in order to predict the housing price based on the area in square feet of the house, area in square feet is the independent variable and house price is the dependent variable. We also have understood what is the mathematical equation used internally by linear regression to identify the best linear relationship between independent variable and dependent variable. Using Scikit-learn, we have understood how can we import linear regression model in our source code, how we can train the model with the help of training data, and how we can predict a dependent variable with the help of a well-trained linear regression model. We can also check and compare the accuracy of the model with the help of score method. Hope you have enjoyed this session. Thanks a lot for watching this video.